And when you write the name of an organic compound, I'll give the summary because it's new, everything new for you. Therefore, I'll give a small brief summary since others have not joined. So you can get that benefit also. Now, first thing. So in any organic compound, carbon is present. First, you have to select the carbon chain, right? The longest carbon chain containing the functional group. Functional group means what? These are the groups. So it's given in your, you can get the resource book from the NIE website. So this resource book, you can see page number 17, organic chemistry resource book, page 17. They have given the functional group, right? Functional group, the name of these are the main functional groups. See, if COOH group is there, then we call it carboxylic acid, and example vinegar or acetic acid. So it's, and the name, when you write the name, it's oic acid. That is the, finally we write the name of the functional group after writing all the other groups at the beginning of the name. And these groups, they will not give this list in the exam. You have to remember all this in the correct order, in the correct sequence, because that is like the activity series. So from the priority list, so priority order, the highest priority, carboxylic acid, then ester, like that. Now you can see this this compound. I'll move back to the paper. You can see there's a OH group. You can notice here OH group is there. So if OH group is there, that is a functional group here, because C and H not functional group. So you can see in this one OH group, if OH group is present, so we have to name that as an alcohol. Can you see here? Alcohol. Here can you see OH group? So example, ethanol, C2H5OH, methanol, CH3OH, propanol, butanol, like that. So you had done the O-level chemistry, you had done alkanes, right? Meth, prop, like methane, ethane, propane, butane. With increasing of the number of carbon atoms, the name changes, right? Now it's alcohol. It's an alcohol, but the name changes with the number of carbon in the, yeah. Okay, so we have to name this as an alcohol. So the name ends in all, right? Methanol, ethanol, propanol, butanol, pentanol, hexanol, heptanol, octanol, like that. And if it is not a functional, imagine now, why this hydroxy also there? Imagine now with COOH, imagine in a compound you have both this. COOH group also there, OH group is there. Then what happened? We give the priority for the COOH group, because it has, you can see they have given in the priority order here, the topic here. This is there, no need to copy down this, is there in the resource book, unit the organic chemistry, page number 17. So then this become hydroxy, and we go for the oic acid, the functional group. So when there's more than one functional group, then we go for the highest priority, and rest of the groups we name as substitute group or the hydroxy. So but here no other priority, also no other functional group other than OH here. Therefore we go for all alcohol. But these halogens, so this iodine also they are attached. You can, that example that that is 2000. This is 2006 or A level 10th MCQ. So you can see iodine is there. So this iodine and OH. So when both iodine and OH there, so again we have to refer this. What should come first? So the highest priority OH, then we have to name this as an alcohol, and iodine, this become iodo. So halogens will never become the functional group. Right? I mean functional group means like it so because it's become like just chloro, bromo, iodo, fluoro, like that, halogens, nitro, NO2. So it become a substitute group in the presence of OH group. So those things you have to remember first. Then number 2, okay, after identifying the father, there's a triple bond also there. That is, if there's a triple bond, we call it an alkyne. Alkyne, ethyne, ethine, propyne, like that, alkyne. It's an alkyne, so it's a triple bond. When there's a triple bond, the name ends in ine, I-N-E. Ethene, ethane, ethene, ethyne. So because alkane, alkene, alkyne. So we had you have done all over chemistry, I think, alkane and alkene. This is alkyne when there's a triple bond. Okay, so those are the things, the important groups you have to identify in this organic compound. Okay, that is the first thing. After that, you have to number this, number the chain. You have to number the chain at the beginning. So you have to number this. Start in a carbon chain, you have to number. So how many carbon in this chain? 1, 2, 3, 4, 5. So you can't number the way you want. You have to number this chain giving the lowest number to the functional group. Lowest number to the functional group. You have to give the lowest number to the functional group. So what is the functional group? OH group. You have to start numbering from OH side, not from left corner. You have to start from the right corner. Why? You have to give the lowest number to the carbon where the functional group is attached. And the second highest priority, the triple bond should get the lowest number. Okay? So your longest chain should include the functional group, and any double bond or triple bond also should be included in the longest carbon chain. So we'll number the carbon chain now. 1, 2, 3, 4, 5. So there are 5 carbon in this chain. Carbon chain, there are 5 carbon in the chain. So if there's 5 carbon, you call it pentane, but you can't tell it pentane because it's not an alkane. So it's actually pentanol. So it's pentanol because OH group is there, it's an alcohol. They will never ask in the exam any of these rules or the procedure or the method or the steps involved when writing the name. They will never ask in the exam. So you ask to write the name. This is an MCQ, but when you write the name, you have to remember those things. Or if you only can copy down in short form in your short notebook or somewhere. Okay, so what is the first step? Selecting the longest chain, selecting the longest carbon chain containing carbon backbone, containing the functional group and any double bond or triple bond, and containing maximum number of substitute group. So this is called iodo. That is the only substitute group here, iodo. Halogen, if it is fluorine, fluoro, chloro, bromo, iodo like that. So this is iodo, IODO. So now you have to write the name. When you write the name, you have to represent to which carbon they are attached to. Iodo is attached to the 4th carbon. Iodo is attached to the 4th carbon. Right? Now, who has joined it? Zishan, you can post the answer because you know this everything. You were in the class, so you joined. So there's a new comer today. That's why I explained. I give a small summary. So you can. I told you to do all this at home, and you can post the answer on chat, and then I can comment on your answer, right? If there's any mistakes, Zishan, right? So now, Chenomi, you have to write the name of this organic compound. First, you have to write all the substitute group. That means this iodo is a substitute group. The main functional group is OH. We have to name this as an alcohol. You have to represent to which the double bond begin with the triple bond begins with the 2nd carbon. That also you have to indicate in your name from which carbon the triple bond begins and to which carbon iodo is attached. So all this because after reading that name, anyone who reads that name should be able to draw the structure without any issues. That's why. So therefore, we can't do any mistake when we write the name, because otherwise, if anyone who read this name and drawing the structure will draw the wrong structure, right? So how to write the name? You have to write 4 iodo. 4 iodo. And everything you can write in simple, no problem. No need to start with a capital letter. You can write all this. So 4 iodo. After that, then is pent. Why pent? 5 carbon. No space. Iodo and pent, no space. 4 iodo pent. Triple bond now we have to indicate. Triple bond begins from the 2nd carbon. Then you can write 2 ine. Pent, 2 ine. YN. Don't write YNE because if you are ending the name, then you can write propyne YNE. But in the middle we omit simple E and we write YN. 2 ine. Then it's pentanol, actually pentynol, but you have to indicate the triple bond. That's why 2 Then OH attached to the 1st carbon. Therefore, we write 1 ol. 1 ol. So 4 iodo, pen, 2 ine, 1 ol. Imagine if someone read this name. Let's see whether anyone who read this name should be able to get this structure again. So let's see how to do it. Now, first, if you are given this name in the exam, you should be able to get this structure without any issues. How to do it? So if you are given this name, forget about don't look at the structure. So what is pent means 5 carbon. So you write here 1, 2, 3, 4, 5. Look at here 1, 2, 3, 4, 5. Okay, so 5 carbon. Imagine you are from the name, we are going to get the structure again. So you have to look at pent. Pent means 5 carbon. Then you can have to check what are the substitute groups attached? 4 iodo. Then you have to start numbering. 1 all. So you can write either side. If you only can turn this completely upside down, then OH come to the left side. Therefore, you can start numbering from this way or that way, no problem. So I'll write here this one 1 to the first carbon OH group is attached. So 1 all, 1 all means alcohol OH group. Then after that, then 2, 3, 4, 5. Then you can say at the beginning of the second carbon triple bond. So I'll put at the beginning of the second carbon triple bond like this. Why 2 ion triple bond. After that what? 4 iodine. Fourth carbon iodine is attached. Fourth carbon iodine is attached. Right. Now you can. That's it. Now you have to make 4 bonds around each carbon atom by putting hydrogen. So to this carbon you have to add 2 more hydrogen. Why? To make it 4 bonds. This carbon already there are 4 bonds. Second carbon already there are 4 bonds. No need to attach any more hydrogen. Third carbon also already there are 4 bonds around that carbon. Therefore no need to attach any hydrogen. But this iodo thing only 3 bonds. No, you have to attach 1 hydrogen. Fifth carbon you have to attach how many hydrogen? 3 hydrogen. Why? To make it 4 bonds. Then that is called the displayed formula. This is called the displayed formula. Then you can if you want, you can write this way also. Structural formula is CH3CH. So iodine you can attach separately since it is substitute group. Then carbon, there's a triple bond and C, and then you get CH2OH. So we get the same structure again. Understood? So if you are given the name, you should be able to draw the structure. If you are given the structure, you should be able to write the correct name. Is that clear? If you have any doubt about this writing the name of this compound, when you do more examples, you will automatically remember this. Don't need to memorize the method. So you will remember the method automatically when you are doing some examples like this. Is that clear, Chenumi? Do you have any doubts? If you have any, you can ask through chat or can unmute. Okay, right. So that's how you write the name of this organic compound, right? Then number 16. Sijan, have you done this? You should be able to do this because you have more practice. I mean, you have done a lot, right, with me? Okay. Then you can pause the answer on chat if you have done the 16th one. So let's see how to do the 16th one. This CO2H means actually it's COOH. You can write here CO2H. That means there are 2 oxygen. That is COOH. So you can see the priority list, the resource book. You can see resource book, the highest priority carboxylic acid. That means you have to name this as carboxylic acid. Okay. Then all the other groups become what group? Substitute groups. So the side groups attach. So therefore this is a CH3 will be a side group. CH3 will be a side group. I'll highlight that. Right. That is a side group. Then what else? CH3 means methyl group. But if you don't write what is CH3, it is called methyl. If it is CH for methane, methyl group attached to the carbon. And then there's a double bond O, that is called oxo. Oxygen is oxo. OXO, that is also a side group. Because we had to write the side group, all the side groups at the beginning of the name. Oxo. Then you have to name this as carboxylic acid like propanol, and the double bond is also there. Double bond also there. We have to select the longest chain containing maximum number of carbon atoms with double bond and other side groups as well. So I'll number the chain now. Numbering should begin from CO2H. Why? Carboxylic acid, the functional group should get the lowest number. So number 1 here. Then number 2. Number 3. Number 4. Number 5. Number 6. So there are 6 carbon in the longest chain. There are 6 carbon in the longest chain. Right. Now, what is the first step when you are writing the name? Okay, Sijan, you have given the name, no? 2-methyl, 2-oxo, actually not hexa, because there's a double bond, Sijan. Hex, 3-enoic acid. Hexa, not hexa, because you have to omit simple A, right? Okay, everything else perfectly correct, Sijan. Your answer is perfectly correct, except this simple A you have to omit in hexa. It just X3-enoic acid, right? Okay. Then I'll write the name. How to write the name? First you have to write all the substitute groups at the beginning of the name according to their okay. Now tell me, the next problem is this. When you're going to write the name, what should come first? Oxo or methyl? There's a problem. What to write first? So there are two substitute groups, so side groups attached. So we have to write all the side groups or the substitute groups at the beginning of the name according to their alphabetical order. According to their alphabetical order. So what should come first? Methyl or oxo? What should come first according to the alphabetical order? 5-oxo or 2-methyl? What should come first? Yes, can you guess? It is? Very good, yeah. Element only, yeah. Methyl should come first. Not the number, actually. Sometimes you might think, because of number 2-methyl. No, not the number we consider here. The name, alphabetical order. So the first letter of the name we have to consider here. So then you get here 2-methyl. Right. Then after that, when you write the name, always you have to put a dash between the number and the name, the first letter of the name. You have to put a small dash like this. And after that 2-methyl, then after that, what is the next substitute group? Oxo. Then you have to write oxo. Oxygen is attached to the 5th carbon. Then write here 5-oxo. 5-oxo. After that, the longest chain 6 carbon. That means hexa. Right? But you can write hexanoic because it's in there and alkene. Hexene like that. But that also you have to write at the beginning of which carbon? The double bond. At the beginning of 3rd carbon, the double bond. Double bond is at the beginning of the 3rd carbon. Therefore, you write here without leaving any space, hex 3 in. 3 in. In means why 3 in? At the beginning of the 3rd carbon, the double bond. 3 in. But you can't just write. You don't write 3 in 1-oic, because if it is carboxylic acid, you can see here the prior place, the name ends in oic. Right. So it's 3 in, no need to write here 1-oic, because in any organic compound, COOH is at the beginning. It's always number 1. When the COOH, we have to start with that. But OH group can be attached to any other carbon. Right? OH group can be attached to any other carbon. That's why OH we have to write the number, but it's not necessary to write 1-oic or 2-oic or 3-oic like this. Therefore, it's anyway is 1. Therefore, we write what? Just enoic acid. En plus oic. Then we call it enoic acid. Enoic acid. Between enoic and acid there must be a space, because it's a carboxylic acid. It is a carboxylic acid. Is that clear? So this is how you write the name. Right? When you write few examples, you will learn it. You will learn this one by one. So the same procedure. First you have to write all the side groups at the beginning of the name with the according to the alphabetical order with the relevant number to which they are attached. Plus you have to write at the end. You have to write at the end of the name. You have to write the functional group name. This oic acid, but before oic acid, between hex and oic, you have to write there's a double bond at the beginning of 3rd carbon. That's why 3 in. 3 in because of the double bond. Is that clear? I think Seshan, you must be completely okay with this. No need to ask. But Cheremi, is that clear? Or do you have any question to ask? Right. Okay. So let's move on to the 17th one. Shall I raise the screen? 17th one, that is 2010. Every year you can see, if you go to the last, now if you can, now I have given here, after first we discuss all the carboxylic acid, how to write the name, all the alcohol, how to write the name. We did separately, each functional group we discussed separately. I have sent you Jeremy all those tutorials. After discussing this, you can do them alone, and if you have in doubt you can ask, or you can request the recording also to correct them. Right? You can get it corrected by requesting the recording for the last month. You can make a small payment and get it. Now 2010 A level, now you can see every year they ask a question from this, right? So even new syllabus last few years also they ask, because the organic compound with the new, whether it's old syllabus or new syllabus, the organic compound won't change, the name also same. Now This one can you tell? See again, there's a what is the functional group here? CO2H. CO2H means COOH, right? That is the functional group. That is number one. Let's see the longest carbon chain. You have to start numbering now from the functional group. From this carbon, you have to start numbering. COOH. CO2H means COOH. After that, you can put this one. That is the next adjoining carbon is what? It must be the continuous chain. You can't break the chain in the middle when you're numbering. So it's number 2. This CH. After that, you can go either left or right. When you're going towards the left side, you get more carbon. The carbon chain is lengthy. Therefore, instead of going towards the right side, because only one carbon, CH3 only, therefore we take this CH3 as a side group attached to the second carbon, and we move towards the left side. Towards the left side. Then you write number in the remaining carbon atoms 1, 2, 3. Here is 3, and at the beginning of the fourth carbon there's a double bond, and this is 5 and this is 6 here. And then you come across one more a similar side group, CH3 group. There are 2 CH3 group. Both this become substitute group or the side group. Now how to write the name? You write this green one. So the CH3 group is also called methyl group. What is that? Methyl. CH4 is methane, methyl, or CH3OH methanol, methyl group. There are 2 methyl groups. So how to write this? 2 methyl, 3 methyl O. You can write, because anyway the alphabetical order the same thing, right? MM. Then you can write 2, 3 instead of writing 2 methyl, 3 methyl. You can write 2, 3 dimethyl. You have to put a dash before you write dimethyl. Now remember, when you consider the alphabetical order, don't consider this di, tri like that, because we consider the name of the side group for the alphabetical order, not the di, tri or the number of groups attached to the same group. So this dimethyl, and after that 2, 3 dimethyl. Then you have to indicate what? Now how many carbon in the longest chain? Hex. Hexane. So you can write here hex. Hex means there are 6 carbon, and then at the beginning of the fourth carbon there's a double bond. Then you write here hex 4 ene. If it is triple bond yn. If it is double bond en, 3 ene, and it's oic acid, 3 enoic acid. 3 enoic space acid, right? So we did a similar one before also. You can see the similar structures, they slightly change, and because anyway the functional group they can't change. So any of them should belong to that priority list given in the resource book. I think Sishan, your answer is 2, 3 dimethyl hex 4 enoic acid. Perfectly correct, Sishan. So you have got it now, this method. So you can answer even your paper. Definitely, Sishan, now you have got the computers to do it. You were there from the beginning when I started this organic thing. 2023 A-level paper also, you will get full marks for this question, because sometimes they can give this in the structure and ask you to write the name. Right, I think you're okay now, right? Okay. So, but you should avoid any careless mistake when you're writing, because no part marks, either full marks or 0 here. Right. Then propionyl. Prop means how many carbon? 3. YN means there's a triple bond. L means aldehyde. If all means alcohol, L means aldehyde. I'll underline this. L means aldehyde. Aldehyde. Aldehyde means CHO group. If I expand that chain, it's like this: carbon, double bond OH, and it is attached to another carbon here. This is called the aldehyde group. Aldehyde group. So that also at that also always at the terminal of the chain. Aldehyde group. When I expand, it's like this. Around carbon there are 4 bonds. So what is this called? Aldehyde group. And CHO, if you expand, it will be like this. So therefore at the end, so out of the 3 carbon, 1 will be this, and there are 2 more carbon, and in the middle there will be a triple bond. Can you guess the structure? I think you cannot post the answer on that. If you only can try it. So CH3 triple bond CHO. Yeah, good, very good, Sishan. So your answer is correct, very good. Right. So he has posted the answer CH3 dash CH3 triple bond. So you can type the triple bond here in the chat. Right. So I'll write here. How many carbon here? Prop means 3 carbon. If you want to get number the chain like this, 1, 2, 3, prop means there are 3 carbon. And at the big, you can write, you can put number 1 this side, left side or right side, no problem, because you can turn the molecule by 360 like any direction. So then the CHO group at the beginning is like carboxylic acid. CHO also always number 1, therefore we don't write 1 al here, just propanal. And at the beginning of this, but anyway there's no other possibility. You cannot put the triple bond between C and CHO. Triple bond definitely between the second carbon and the third carbon, because you can't put a triple bond between 1 and 2, because then it will exceed more than 4 bonds around this carbon atom. Look at here, if you put a triple bond here, what happens? Now already there are 3 bonds. Already there are 3 bonds. If you put here triple bond here, what happens? Around this carbon, how many bonds now? Around this carbon there are 6 bonds. That is not possible. Carbon atom cannot form more than 4 bonds. Is that clear? Right. Then, so triple bond because of iron, and complete the rest with hydrogen. So first carbon, or anyway there are 4 bonds. So no need to add any more hydrogen. Second carbon, already there are 4 bonds around second carbon atom. Third carbon, you have to put just 1 hydrogen. I think Sishan, you have to change your answer. No? You put 3H3, CH3, no need. Because you can't put a triple bond with CH3. Is that clear, Sishan? When you put a CH3 group, you can't put triple bond. Only one, you can't have a CH3 group. CH3, when there's a triple bond, because already there are 3 bonds, you cannot have more than 1 hydrogen either side. Either side, maximum 1 hydrogen. If you put, this is called ethyne. What is this called? Eth means 2 carbon. Ethyne, alkyne. So this is C2H2. Right? C2H2. Okay, now correct. CH triple bond C, CHO. Okay, now correct. Chanumi, is that clear? Got it? Okay. Then we'll move to the next one. 2012 A level, question number 3, MCQ. I'll erase the rest. This one. Okay, how to write the name? Now again, check what are the groups attached here. So OH group is there, CO group is there. So check in the I think Chenumu, I have given this. You can refer the resource book. This priority order list I have given in 7.5. Now IUPAC nomenclature organic compounds 7.5 tutorial. The last page I have given this. So you can see when there's CO group, that is a ketone. So this CO group there and OH group is there. Which one has the higher priority? I encircle that. CO or COH has higher priority. CO, right? CO means it look like this. Around carbon and there must be 4 bonds. It like this. Understood? Right. Then now that become oxo, no? You have to write this as on. The name should end in on, and OH become what? Hydroxy, because you can't take both these as the functional group. So you have to, this main functional group is ketone. You have to name this as a ketone. Ketone, the name ends in on. So example, propanone. This is actually most of the ladies, they use this, right? What is the commercial name, like common name we use for this one? You even in O-level chemistry you might have done this polar and non-polar organic compounds. So it's moderately polar one, acetone. Acetone. This is acetone. This nail polish remover, acetone. CH3, CO, CH3. What is called acetone. Acetone. But according to the International Union and Pure International Union Pure and Applied Chemist, so IUPAC. IUPAC stands for International Union and Applied Chemist. So that organization, international organization, so according to their name, so this should be propanone. Propanone. propane means 3 carbon, because of 3 carbon here. So it's on. When you add on, you omit. If it is alkane, C3H8 C3H8 means that is the LP gas cylinder. Now these last few years, I mean, this was like kind of it was in the news also, no, the LP gas cylinder, the composition C3H8, that is called oil chemistry also done it, propane. Now it's C3 now, but H6 and O. H6, not H8, H6, and then there will be a oxygen atom in the middle. Then therefore, instead of writing propane, you omit simple E, the last letter, and add ONE. That is a suffix here, ONE. That is called propanone. Propanone. It's a ketone. The main group, the common name is ketone, the main group name, and the functional group name. And in day-to-day life we use acetone, nail polish remover. The real name is propanone. Okay, so if you want, you can copy down that also separately somewhere. Propane, propanone, 3 carbon. And now we CO, that this on, and then this become hydroxy. Now let's move back to the again the question here. I'll read this. If I still right now, let me know. Right now, what is OH? So the main functional group. Oh no, not OH. OH become hydroxy. This becomes the substitute group. Oxo is the main group now. This is called oxo. Sorry, not oxo. On functional group. Functional group I'll highlight red, and the others I'll highlight green. Then see, isn't it? OH is side group. Then methyl will be side group. Then all this we can select for the longest chain. So let's see the numbering now. Numbering should begin from what? Numbering actually from the functional group, but here the functional group is the middle of the chain. Therefore, you can write here 1 because this cannot act as a side group. The main chain, the longest chain should include functional group as well as the triple bond or double bond. Any double bond or triple bond should be included in the longest chain. Therefore, the longest chain will be this one. You have to start numbering the longest chain from one end. You can't start numbering from the middle, because this oxygen atom in ketone, oxygen can be anywhere. Oxygen can be attached to this carbon double bond, or oxygen can be attached to any other carbon here. This side, this one, oxygen can be attached to anywhere here. If I make here 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, you can have oxygen in anywhere. That's why you can't start numbering from ketone group or oxo on. So the numbering, but then we go for the lowest number for the functional group. So there are two possibilities. Either you can start numbering from left side or right side. Which one is better? Can you guess? Okay, I'll give the two options now. One option is this: 1, 2, 3, 4, 5. So these are the continuous chain. You can't break the chain from the middle. You can go L shape or whatever the shape, it doesn't matter, but it should be continuous from starting from one end of the longest chain. So the other one is this: you can start numbering from this end: 1, 2, 3, 4, 5. Which one is better? That orange one or blue one? Which method is numbering the best method? Can you guess? Okay, Sishan gave the answer also. So from which method you get the lowest number for the functional group? The functional group also get the same number, right? Number 3, 4. Blue one also number 3. This orange one also number 3, the functional group. Then there's no choice from that. You don't have a choice from that. So then we go for the next one. Next one we give the higher priority number in lowest number. Triple bond or double bond should get the lowest number. If not, you can write it. First you try to give the lowest number for the functional group. When numbering, first we try to give the lowest number for the functional group. When there's more than one possibility, then you go for the double bond or triple bond, the lowest number. When that also done, again you have more options. Then you go for the double bond, the lowest number for the side group or the substitute group. Again, I'm repeating. First you have to give the lowest number for the functional group. When there's more than one possibility, then you go for the double bond or triple bond should get the lowest number. When that also more than one option, then you go for the side group, the lowest number. Now here we stop from the second one because from which one, the orange one or blue one, the triple bond get the lowest number, from which one? Anyway, the own thing, ketone, the number 3, you can see the red one, highlighted one, number 3. There's no choice from that. We go for the blue one. Why? Triple bond get the lowest number. Not the OH. OH is hydroxy. OH is hydroxy. That is a substitute group. Is hydroxy. This is methyl. Methyl. Right. Now, 19th one, you write 5. What should come first? Hydroxy or methyl? Alphabetical order. All the side groups you write at the beginning of the name according to the alphabetical order. What should come first? Yes? What should come first? 5-hydroxy or 4-methyl? Alphabetical order. Yeah, A, B, C, D, E, F, G, H. Yes. It's 5-hydroxy first. Okay, you can write the name now. If you have got a printout, you can write here itself, or else you can write separately and later you can complete it again. 5-hydroxy. 5-hydroxy. After that, 4-methyl. 4-methyl. Why 4-methyl? Fourth come. I'll erase the pink or the orange one because that's wrong. That method of numbering is wrong. Therefore, we'll keep the blue one. 4-methyl. After that, what should come next? So then we have to represent it's pentine, but you can write just pentine. Why? It's pentine. Pent means 5 carbon, ine is, there's a triple bond, but you write between which carbon or at the beginning of which carbon the triple bond. 1 ine, and it's you can write just pentanone, pentinone or pentinone. You have to write here 3 on. Why 3 on? Because I told you this oxygen can be attached to any other carbon. Therefore, you have to write here methyl pent means 5 carbon. 1 ine. Why 1 ine? At the beginning of the first carbon, triple bond is there. That's why 1 ine. And again, you have to write 3 on. Why 3 on? At the beginning of the third carbon, functional group, that is on alcohol, maybe ketone. 1 on. Pent 1 ine 3 on. Pent 1 ine 3 on. Is that clear? So by looking at this name, you should be able to get that structure back. That's what it means. You should be able to get that structure again. Okay, 5-hydroxy, 4-methyl, pen, 1 ine, 3 on. Sishan, you got the same thing, right? Any mistake in 1-hydroxy? It's not 2-methyl. It's 4-methyl, Sishan. Your number in you have given the priority for the OH group. No, that's the thing. Is that clear, Sishan, your mistake? The numbering has gone wrong. That's why you have got this name. It's not 4 ine, it's 1 ine. You can't name this as an L. Seshan, you can't name this as L because it's not an aldehyde group. Only hydroxy, that all alcohol group and the own ketone group is there. Understood? The mistake. So you have not selected the correct functional group, Seshan, and the second one, the number in the problem, right? Okay. So then next one, number 20. Can you try it again? Can you try this 20th one? 20th one, what is the functional group here? So aldehyde group is there. Anyway, bromo and this is also the this oxygen there. But anyway, you can see here this COO. COO. It's not COOH. It's COOR. When this group is there, we call it ester. I don't know whether if you're doing biology, you know this glycophosphate bond or something. Amino acid, all there's a ester group. You learn sweeter ion, right, or something like that. So this COO group, and this side this is called R group, that is ethyl group. This is called ethyl, ethane, ethyl, ethanol, CH3CH2OH and CH3CH2OH, ethanol, ethyl alcohol. This is called ethyl group. If it is CH3 CH2OH called ethanol or ethyl alcohol. This is ethyl alcohol. So when you take only this wall, we call it ethyl group. Okay, or ethanol, because that is also, if you can contract this again more, you can write here C2H5 C2H5OH, but OH you will, you know from O level also, you know, you have learned this ethanol. So OH group we don't hide, because you combine C2 and H5, 3 hydrogen, 2 hydrogen you can combine, but the last hydrogen in the OH group we don't add. Then otherwise you can make it C2H6 only. You don't write that, then we can't, difficult for us to identify whether it's alcohol or not. You don't write here C2H6O, because if you can add this also here and then make it like this, but it does, then is, we don't know whether what is exactly the group of organic compound. That's why we leave OH separately, and we don't add the hydrogen of the OH group to the 5 hydrogen here. That's why it's called ethyl group. Then this is called ester. You can see the prior list. So this is bromo, the function, that's a side group. So in the presence of COO group, in the presence of COOR group, this CHO become what? A side group. Number 20. So you can write here just this, it's like this now. Then it's become oxo here. Oxo, because that also we have to select that carbon also should be included in the longest chain. Right now ethyl there as a side group. Actually not side group, because ethyl is not directly attached to the main carbon chain. Numbering should start from the functional group. You can look at the priority list here. That's little difficult than the ones we discussed. Can you see here COOR here? COOR, tell me. After COOH you can see COOR. That means what? C double bond O, CH3O, O R means alkyl group, ethyl, methyl, whatever like this. If you have COOR, that is called ester group. And the name ends in O8. Name ends in what? O8, O8E, ester. Right, now let's move back to this again. Right, so this is oxo. So I'll highlight the functional group, the side groups with different color. I'll highlight this with green. Oxygen, so I'll write here oxygen is O, and then bromo there, and only those two, no, oxo and bromo only, oxo and bromo only. So how to write the name now? What should come first, oxo or bromo? Number 20. Wait, 3 bromo 5 oxo. Now this is also very important. Now when you number in, you can't write here 1 2 3 like this. Look at the screen, look at the screen. You can write 1 2 3. There's a gap here because this oxygen is not directly attached, because this carbon, this CH2 carbon is not directly attached to this. Therefore oxygen come and break this. Therefore you can't start numbering from this side. So the numbering should begin from this one. Ester group. 1 2 3 4 5. 5 carbon in the longest chain, and on the 5th carbon the oxo there, and on 3rd carbon brome there. So you write them are there. This is ethyl is there, but ethyl there's no number attached. Like ethyl is attached to the oxygen. Therefore, when you're writing the name of an ester, so you write ethyl first and leave a space, because we can't show that it's whether it's attached to any carbon. No, because it's attached to the oxygen. So carbon chain is not continuous from ethyl itself. Therefore, ethyl is space. Ethyl is space. After that, then you go for the same procedure, same as before, alphabetical order, the side groups. Bromo, 3 bromo, 3 bromo. After that, 5 oxo. 5th carbon, there's an oxygen attached, oxo. And five oxo, 2 Right, 5 oxopent. Why pent? There are 5 carbon in the chain. Pent, and at the beginning of which carbon this double bond 2. 2 in 2 in O8. Why O8? Because of ester. Ester, the name ends in O8. Why in? At the beginning of 2 in, why at the beginning of the second carbon double bond? Why pent? 5 carbon in the longest chain. Why oxo? Fifth carbon, there's a oxygen attack. And why 3 bromo? Third carbon bromine attack. Why ethyl? Ethyl is written separately without directly attaching to the main name, because it's not directly attached to the first carbon. CH2, this CH3 CH2 is not directly attached to the C1. That's why. Otherwise, therefore, you can't include those 2 carbons. This ethyl group, the 2 carbon, you can't include in the longest chain. Understood? Any question here? Any question? So this one we take separately as ethyl. Ethyl. Now, Sijan, your answer 3 bromo. No, 1 ethyl, not it. Ethyl you have to take at the beginning of the name. Right? 3 bromo, okay. Then for 4-mile we don't take, because that's for actually we take that carbon also for the longest chain, Sijan, right? CHO, that carbon. Then this oxygen become oxo. Right. Then so that's little difficult than the previous one. This is 2013 A level. Let's move on to the 21. Shall I read this? Done? Shall we? Then 21. 21. You can see there's a OH group. And there's a ketone group. And there's a NH2 group, and there's a double bond. These are the main things. Other CH, other everything else. So we have to write this as what? Alcohol no, ketone no, what? You can see the priority list. NH2 at the very bottom. Look at the screen. NH2 is below OH. So these are the 3 groups there. CO group there, OH group there, NH2 group there. Therefore, we have to name this as what? Ketone or alcohol or amine? Tell me. If we name this as a ketone, or the name ends in on, then the other 2 group become what? The other 2 group become hydroxy and amino. Okay. So that's what we have to do, because the highest priority ketone, no? The other 2 groups become side groups like this. And this is the main group. CO, that is on. Is that clear? When CO become on, the others become side group. Amino and hydroxy. Is that clear? Okay. Then so this is this order you have to remember, right? Because in the exam they don't give it. Table 1.6, page number 17 in your chemistry organic chemistry resource book. Okay, so then let's move back to this again. The name. So it's you have to name this as, I will highlight the functional group. You have to name this as on. Propanone or butanone or pentanone or oxanone, like on. Name should end in on. And the others become now side group. So the substitute groups, what? OH is side group. And NH2 is side group. So this is hydroxy, that is amino. This is hydroxy. This is amino. This is hydroxy. Then in okay, we have to start number in the chain. Number in, because this ketone group, CO group, can be anywhere in the chain if you can attach that here or any other place. Therefore, we don't need to start numbering from that one. We start numbering from this. So, but anyway, the CO should get the lowest number. Therefore, we start from the right side numbering 1, 2, 3, 4, 5, 6, like that. So we have to write the name by including all the substitute or side groups at the beginning of the name according to their alphabetical order. All the side groups should be written at the beginning of the name according to their alphabetical order. What should come first, Chenemi? Hydroxy or amino? What should come first? 6 amino or 1 hydroxy? 6 amino or 1 hydroxy should come first. Yeah, alphabetical order. Amino, not the number. We consider the first letter of the name. Amino, alphabetical order. Amino should come first, but amino is attached to the 6 carbon. Therefore, 6 amino. No need to start with a capital letter. You can write everything in simple. 6 amino. After that, you can tell hydroxy. So the OH is attached to the first carbon. That is 1 hydroxy. After that, total the longest chain 6 carbon, that is hex. In the hex 6 carbon, within this 6 carbon, the 4th carbon, at the beginning of the 4th carbon there's a alkene. Therefore we can write here hex, no space between hydroxy and hex. Hydroxy, hex, what, 4-ene, 4-ene, or not ene, 4-en, because we have to omit this E because we are going to attach one more here. ene. After that, the functional group, the CO, that is at the beginning of the oxygen is attached to the second carbon, therefore 2 on. 4-ene means double bond is at the beginning of the which carbon? Double bond is at the beginning of the 4th carbon, that's why 4-ene. Why 2 on? 2 on means the functional group, the ketone, that is at the beginning of, that is on the second carbon. Understood? Right. So what is the name now? 6 amino, 1 hydroxy, hex 4-ene, 2 on. Sujan, your answer is correct. Very good. Understood? Okay. Then shall I erase? Can you try the next one alone without my help? Can you try the same procedure? Nothing new. Try one alone and then no problem. You might do mistake 1 or 2. Then you have to learn it by doing it. So otherwise, if you are straight away copying down my answer, the final answer, then you will your thinking ability is not improving. Therefore, with errors it's okay, because even Sejan, like, he did a lot of mistakes at the very beginning, but now he's really, like, he's good now. Sejan, you also can post the answer on chat. You have to start numbering the chain from the functional group. Okay, check the priority list. 7.5 at the last page, I have given the priority list. And all the steps become side group, and you have to include the triple bond also in the longest chain and number it. Okay. When you are done, Chanmi, please reply on chat. After that, I'll write the name. Sushan, you also can do write that. Okay, Sishan, you have sent. Okay, Chani also gave. Right, good. Let's see. You can compare the answer. I will not read your answer for this 19, 22nd. No, yeah. 2 hydroxy. Good. Methyl. Actually, it's 2 methyl. I think it's 2 methyl. Uh, okay, and oxo there. 5 oxo. 3 hex 3 ionic acid. Wait, uh, I'll do it from the beginning. Now, what is the first task? Selecting the longest chain containing the triple bond, double bond, and the functional group. So, you have to select the longest chain like this. This is the longest chain. This is the longest chain. And you have to start numbering this chain, giving the lowest number to the functional group. So, all this becomes side groups. So, the substitute group. 3H3 will be substitute group. OH also substitute group. And OXO also substitute group. I highlighted them green. Now tell me this, the terminal CH3 don't take as a substitute group because we go for the maximum number of carbon atom. We have to select the longest chain. So 1, 2, we go for we move towards the right side, the left side towards the instead of right side only 1 carbon, CH3 only. Therefore you have to, it should be continuous chain, right? There can't be any break in the middle. All the carbon atoms should be attached to each other. So it's 3, 4, 5. Now tell me you have stuff from this, right? You have selected this also 5 method, no? 6 methyl, I don't know what. When you go for 6 one, then you don't take this as a methyl group. So it's in the longest chain. It is in the longest chain. So the longest chain contain what? 6 carbon. 6 carbon. So these ones act as substitute group, or I mean the side group. Oxo, hydroxy and methyl. Right? Methyl. And COOH is the main functional group here, the highest priority. COOH I'll highlight, that is the main priority. That means actually if you omit all these triple bond and CH3 and all the side groups and the triple bond, if you omit, what will be the name of this compound? Hexanoic acid. This will be hexanoic acid. Hexanoic. Not hexy. If it is hexanoic, then if it is hexanoic, there will be a double bond. It is hexanoic, 6 carbon. It's an alkane. If you omit all the side groups and the triple bond, it will be hexanoic acid, hexanoic space acid. But you can't know hexanoic acid. Why? In this hexanoic acid, there are some other groups attached. That also you have to include at the beginning of the name. Understood? Therefore, there are 3 side groups attached. What are these? Methyl group attached to the second carbon, hydroxy attached to the again second carbon, and oxo attached to the 5th carbon. Now, how to do it? 2, what should come first? Oxo or hydroxy or methyl? Alphabetical order. 2 hydroxy, right? 2 hydroxy. Why? H comes before M and O according to the alphabetical order. 2 hydroxy. I think both of you have started with the same, like 2 hydroxy, correct? After that, what should come first? Methyl or oxo? LMNO. What methyl? 2 methyl. 2 methyl. Before the number and after the number, you have to put a dash, right? Okay. 2 methyl. After that, 5 oxo. 5 oxo. You can't name this as a ketone. You can't tell hexanon or pentanone because it's carboxylic acid. The name ends in oic acid. After that, after 5 oxo, you get what? Then we have finished all the side groups attached. Then we can go for the longest chain. Longest chain contain how many carbon? 6 carbon. Then is hex. Hex ne? Hex. Hex what? You can't write just hexanoic. Hexanoic you can't write. Why? Because there's a triple bond. Triple bond is there. That also you have to indicate. So after hex you have to write what? Before enoic acid. Hex triple bond is attached at the beginning of the third carbon. Hex 3, not in 3 inoic acid. Inoic acid. 3 ine, triple bond is ine. 3 inoic. Why oic? Because of carboxylic acid. Why ine? Yn? Because of the triple bond. 3 inoic acid. Is that clear? That's the name. If you want, you can look at the name and see whether you can build this structure without any Yn. You can't write Yne. So example ethine, propyne like that. It's ethine. Ethine means C2H2. That is this one ethine. So it's ethine. That is alkyne. That is the most simplest alkyne. It's like ethene. This is ethine. So Ine, but since it's the name ends in ethine, we write all three letters. But here we omit E and write only Yn, right? Because it's in the middle. Okay, so any doubts or any questions regarding this name? Is that clear, everyone? Both? No? Shall I erase this? Okay. Now at least you have to do like this. Now again you will forget it, like after a few months you will forget it. So therefore now you can collect these names of you. Now the next round is you have to collect all the maybe Vishaka, Devibalika, Ananda, Nalanda Royal, or any other term test paper. You can check IUPAC names, or you can write any other class. You can check the organic compound naming. You can try it. So at least once a month you have to do at least one example. Once a month. Otherwise you will forget it with time. Definitely you are getting a question from this. So first round you do all the past, because past papers like no mistakes, and sometimes the school term test paper there can be simple mistakes, and sometimes in translation problem there are various issues, typing problem and all. But AL paper they don't, it's minimum like free of errors, those such errors. So if there's a simple error in the question, then they have to give a free mark. Therefore we are very careful about this mistakes in the AL paper. Then number 23. Shall I erase this? Okay. 23 is not hard. Can you write? This is 2016 A level question number 3. Third MCQ. Can you try this alone? Now what is this CO2 C2H5? Shall I expand that and write it? CO2 C2H5 means what? C double bond O C2H5. That is, can you remember we did earlier you wrote the name of an ester. I told you ethyl should be written at the beginning of the name before you write the substitute groups according to the alphabetical. Before writing the substitute groups according to the alphabetical order, we write ethyl, because ethyl, it's a separate group. It is not attached to the main carbon chain. It is linked through the oxygen atom. So this is an ester. So the name ends in O8. Hexanoate, pentanoate, octanoate, like that. Therefore, the main functional group here, ester group. Okay, can you try the rest? And the others become the side group. Remember, when you number in, the numbering should begin from the main functional group, that ester thing here, ester group, or the O8, and then triple bond must be included in your chain. Can you try this? What is CN? CN means cyano. Okay, CN means cyano. When CHO become a side group, it's called formyl. You can check in that priority list, formyl. And when CN become a side group, this is called cyano. Now can you try it? I can do the number in and write the name. I did half of this. Can you try the rest? And post the answer on chat. After that, I'll tell you with the answer. It's okay. You maybe not perfectly correct, but you can make an effort and post the answer on chat when you're done. After that, I'll write the name. Okay, okay, Sishan gave the answer. Chenmi, are you still doing? When you're done, you can. Okay, okay, no problem. You can take time and do it. Yeah, don't be in a hurry. So you can take your own time and do it. Sishan, you gave carried one. Mm. Now, don't write one ethyl. Ethyl you have to take at the very beginning separate without telling the name because it's not attached to the first carbon directly. Can you check the previous ester, Sishan? You write just ethyl at the beginning of the name without writing any number because it's not attached directly to any carbon ethyl. Uh, can you see that OH and ethyl I have highlighted separately, Sishan? So you write ethyl and then space. Then you can write 2-cyano. Everything else correct, Sishan. Only that is the only mistake. Write in one ethyl. So don't write one ethyl. Just ethyl take separately at the very beginning. Very good. Now it is correct perfectly, Sishan. Yeah, correct. We'll wait for Chenmi and if you want, you can try the next one until she is complete. Actually, now in Sri Lanka, local A level, majority of the students enter in medical faculty from the second chai and third chai. So only less than 30% entering from the first chai. Because of this, they don't have time to do this revision. You can imagine now. Just copy now. Earlier I told this is how you should write the name. The teachers, they'll give this long paragraph in the school or even in any other class theory. Select the chain and the first number, the chain, and then giving the lowest number to the functional group, and then write all the functional group at the beginning of the name alphabetical. Right? That they will give the theory note. But you can understand now that is not enough, no? So you have to learn it by doing it. You have to practice many examples like this, then only it goes to your head, because in the exam they will never ask the procedure or the steps involved in writing the name. Okay, Chanami, right, good. You have done an effort, good. Now, 2 dash try now because where you can, okay, one thing, Chanami, you write 2, okay, I'll write the numbering now. Numbering should begin from this carbon, look at here. Numbering should start from this carbon. 1, then here 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5. Now, cyano on the second carbon and 4-mile also on the second carbon. Look at here, Chenmi, this green one. There are two green ones, 4-mile and cyano. Those are the two substitute groups, side groups. If you put a number for this one, then this become oxo. If I put the number here, then because you can't go to that side number in, because you have to do the continuous chain or continuous chain. Number in should be continuous. You can't go to that zigzag pattern that side and this side. Right. So it should be continuous chain, the longest chain containing maximum number of side groups and maximum number of carbon atoms in the longest chain. So we have to write here, okay, what should come first, 4-mile or cyano? Yeah, cyano should come first. Therefore, we'll write here 2 cyano, correct. 2 cyano. Now, Jeremy, you are far better because without now, you can see about 5 tutorials I have done IUPAC names before, right? Before discussing this is the last part of the IUPAC organic compounds naming. Today we are finishing this. So therefore, my advice now, you get the recording of the others. Now you know the procedure. So you try to do the other 5 tutorials and get the recording and correct it. Get it corrected. Right? Then you will be fully okay with this. Right. Now, 2 cyano. Okay. Then after that, what are the next side groups attached to the same carbon? Second carbon, there are 2 side groups attached. 4-mile. Then you can write here what? 2 4-mile. But before all this, there's one more thing. That ethyl thing, can you see here? I'll put a cage around this. I forgot that. Actually, ethyl should be written first, because that is not directly attached to the, that is attached to the functional group. Ne? This ethyl is attached to the COO group. That's why we give a priority for that also, because the functional group the highest priority. So we write here ethyl. Ethyl space. After that we write 2-cyano. You can compare this with the previous ester. I think which one we named ester, similar one we did. Look at 20th one. 20th one also we did the same thing. 20th one, look at the 20th one. See whether if we have violated any rules or the conditions that I explained in the 20th one. 20th and 23rd, same thing, like same compound, same organic compound we are naming. Ethyl 2-cyano. After that, only those two side groups, right? Wait, 4-mile there, 2-4-mile. 2-4-mile. After that, pent. Why? How many carbon is the longest chain? Pent, but for at the beginning of the fourth carbon, triple bond also we have to indicate in our name. Pent, 5 carbon, 4 inoate, 4 inoate, 4 yn, wine, 4 ine means 4 carbon triple bond, OATE, OATE. Why OATE? Because of the ester, because of ester OATE, ester group, the functional group. Why 4 ine? Because of triple bond at the beginning of the fourth carbon, triple bond. And why pent? 5 carbon in the longest chain, 5 carbon atoms in the longest chain. So there's a reason for all this. Why this 2-cyano and 4-mile? Because 2-cyano and 2-4-mile, because second carbon there are these two side groups are attached. Understood? Is that clear, Chenumi and Sishan? Your answer is correct, except that ethyl thing. Right. Now my advice, in most of the other classes, organic chemistry, your batch, I don't think any other classes they have done theory yet. Even now they are doing sixth lesson, most of the other classes, because sixth lesson is very lengthy. So some students sitting with you this A-level paper, your batch, repeaters. Sometimes they have 3 A's in their hand now also, but they can't enter medical faculty from Colombo. 2 A's, 1 B. So don't forget that they also sit in again with your batch. I mean, with you this 2023 or 2022 A-level. So definitely they are targeting, because otherwise they are repeating with 3 A's in hand. They are repeating this exam because they don't want to do dental or vet. So they want to join the best university in our country. Island rank, this is called the South Asian, the rank in say Colombo for medicine. Biology, bioscience also, chemistry also, Colombo the best. More to engineer like that. So therefore, after A-level results, so you have to select, you should get the chance to enter the best university in our country. So all this depends on your, it's a disco. Therefore, now always you should be beyond the others. I mean, you have to be little bit ahead from the others, because when the others are in the place, so you have to be like, you have to do more. Now you are doing revision of the others. They haven't done the theory yet even. That means you have done little bit more than the others. So then that will be beneficial when you are definitely doing theory, this section in school or any other place, you will definitely perform better than the others, because you have previous knowledge. I think that's the good. That's why actually I thought of doing this before you do this in the school. Otherwise, you write a big note and come this with that, having that attitude in your head, in your mind. This is hard. So it's very difficult to teach, because organic section is very difficult. I mean, not very difficult like the physical chemistry and inorganic chemistry. No balancing, no equation, right? We don't write the byproducts even. So it's very easy. The organic chemistry is easier. But many students find it difficult the way because they write a lot of theory here, the note, and they memorize that, but that's not what they ask in the exam. Okay, so after this I'll come to the inorganic chemistry and physical chemistry revision, the remaining parts. Organic chemistry, without theory, with a summary note, you can go, you can continue. That's why. Now, uh, you had enough time to copy down this. Shall we move to the next one? 24th one now. I'll erase this. 24th one. 24th one. Last one, no? Yeah. Can you try this alone without my help first? The last one, both of you. Yes, that is with the not medical faculty. You can enter for genetic engineering. You can, there's a separate faculty in Colombo science faculty, molecular biology and biotechnology. There's a separate department. You can do bioscience and you can do that special degree. I think they select from the first year itself. You can enter that. You can join with that department. All depends on the results. Without doing medical faculty, medicine, you can do that. Molecular biology and I think Tumula, there's this Colombo University science faculty. Opposite to the science faculty, there's a separate faculty that is in the college house. You don't need to enter medical faculty to genetic engineering. And so it's not a problem, the repeater. So anyway, you should be more knowledgeable and you have to do the revision. Now only they are doing revision and trying to enter the faculty the second attempt. But if you can do both in the first 2 years, then that's all right. You have done theory and you have revised. You have done a good revision before your first attempt. Okay, can you give the answer? 24th, Sishan give the answer. So I'm waiting for Cherami. And Sishan, your answer? Yes, okay. It's not hydro, Sishan, it should be hydroxy, okay? But numbering, there's a small problem. Pento, okay, 5 carbon, the longest chain, 4 inal. Don't write 1 nal. Just straight away, you can write 4 inal because anyway, aldehyde group, CHO is L. CHO, here the main functional group is CHO. That's the name ending in L. So you have to start numbering from this carbon. 1, 2. So we will go for what? Left or right? Can you tell me? To which side we have to move number in now? From after putting 1, 2, then third one should come, third one right side or left side? Very good, left side, because then you get the triple bond and the more functional group. So okay, 3, 4, 5. Right. Now this OH become what group? That become the side group because L is the functional group. You check the priority list. OH become the side group. And this ethyl group also becomes side group of the substitute group. So you have to write those two at the beginning because this is not an ester, not to write ethyl like that. So you have to write hydroxy and ethyl there. You have to write them at the beginning of the name according to the alphabetical order with the number. Okay, now you can definitely do it, both of you again. Try the numbering. I think your numbering has gone wrong, Sijan, because numbering should start from the functional group. And when, because anyway it's number 1. There are these groups, COOR, carboxylic acid group. Look at the screen. COOH and CHO. These three always at the beginning of the name. Anyway, it's one. In any other compound, whenever you have these three, it's always at the beginning of the name. Always at the beginning. They always get number 1. Therefore, we don't write 1 nal, 1 oic acid or 1 OA8. Not necessary. Not necessary. Therefore, you can write just inal, YNAL, inal. But you can write 4 inal. 4 ine means what? Triple bond at the beginning of the 4th carbon. Can you try again, both of you? Okay, Sijan, repeat it again. Okay, 2-ethyl, 2-ethyl hydroxy. Now perfectly correct, Sishan. Okay, perfectly correct. So, Chanumi, can you also post the answer on chat? 2-ethyl 3-hydroxy pentoenal. Yeah. Chanumi, when you're done, please post the answer on chat. Chanumi, are you still writing or shall I write it? Okay, you can take time and do it, but if you are doing it, tell me. Okay, no problem. Yeah, you can do it. We'll wait because the last one you can, yeah. No issues, you can do it. After this, we will start a new part, new section. Right, okay, Chanami, I will write it. Now, what should be done first? We have to write all the side groups at the beginning of the name. What are the two side groups? I have put them in green. What is it? Ethyl and hydroxy. What should come first, Chanami? Ethyl or hydroxy first? Those are the two side groups attached to the main carbon chain. Right, ethyl. So what ethyl? You can write the number to which where the ethyl group is attached to the main chain. 2-ethyl. 2-ethyl. After that, hydroxy is attached to which carbon? Third carbon. Therefore, we write here 3-hydroxy. After that, what? Are there any other side groups left? No. Then we have to write the name of the what is this? How many carbon? Penta, no? Pent. Pent, you can write just actually pentanal, or if there's no triple bond, or if then we can write just pentanal. Okay, imagine there were no triple bond, then you can write just pentanal, hydroxy pentanal. But we can't write here pentanal. Why? Because if you write just pentanal, then what? It seems no triple bond. Just carbon single bond like alkane. Al is because of aldehyde. Pent because of pentane 5 carbon. Al means aldehyde. CHO, I have put that in red. Okay, Chanami. Now hydroxy, then we'll write pent, but before you write L, you have to indicate at the beginning of which carbon the triple bond is there. So pent for, if it is triple bond YN, ine, alkyne, for ine, no need to write 1L because anyway any compound CHO group, aldehyde group is at the very beginning, therefore you just write YN, YNL in other words. So why L? Because of, if you only can write that since you are still practicing, the L means because of aldehyde group, functional group, the main functional group, aldehyde group. Then triple bond YN because of triple bond, and triple bond is attached to the fourth carbon, that's why 4YN. Pent means there are 6 carbon in the longest chain. 6 carbon atom in the longest chain. The other best you can understand. Is that clear? So if you yeah, why can't we write 4-mile instead of L? Yeah, good question. Remember, first we are trying to get the longest carbon chain, right? Longest carbon chain. if you write this formyl, then it becomes a side group. Then it becomes a substitute group. Then we have to name this as an alcohol. Okay, because highest priority CHO group. In the presence of CHO group, OH becomes the side group, hydroxy. Otherwise, you have to name this as an alcohol, 3-ol. 1 formyl, 3-ol. That is wrong. Look at the priority list, resource book. CHO is above, OH is below. Here. CHO aldehyde group, that is L. I don't know if you can see because of the writing here. Can see the cursor here. OH come below that. Alcohol group, hydroxy. That's why hydroxy becomes side group and the L become the main functional group. So you can't write formyl when this become the main functional group. Is that clear? Did you get it? So in the presence of the, because you can't write this formyl because that is a functional group. Then you have to definitely write the name, and the name should end in L. If you take this as formyl, then what? Then the name is wrong because you are not taking the functional group according to the priority list. Then it's become alcohol. Then we go for the remaining other group, is the main group is OH. Then it's become alcohol. So that's wrong. In the presence of aldehyde group, the OH become the side group. Okay, is that clear? Yeah, if you have a simple doubt even like that, then you have to ask, right? Okay. But you have to do the other 4 papers because aldehydes I have given a separate question, set of questions separately, like 7.1, 7.2 like that. Alkanes separately, alkene separately, alkyne separately. So without doing any of those, you are doing this straight away today papers, right? Therefore, at least you have got it very good with these few questions. Now the best thing is you go through all those 5 tutorials, 7.1 to 7.5, and try to do it now and then get the recording and compare with your answers. Then you will be fully okay with this. Then let's move to the new part. That is the end of organic IUPAC. Actually, I have given here up to 2017. So the next one you have to do 2018, 2019 and 2020. Right? And 21. So this time paper. So that one I will discuss that after a few weeks, because when you forget this, and I'll come to this again, because otherwise you will forget it with time if you don't touch this for a few months. Now I think I had that also 2000. Organic questions. Yeah, we will discuss that later. I think I had that. Organic conversions. We'll do that next time. Now isomerism. So the next section, isomerism. These are the, like, I am doing this now. You can see the past questions. So new syllabus and all syllabus both, but organic chemistry also there are various, like, different areas where you are always getting questions. According to that priority, I am doing the revision. If you are getting definitely question from that one, I'll do that first, the complete revision. Right? So like that. So I'll put more weight on that, depending on the weight that they put on from that area in the yellow paper. So certain areas, certain parts, I will not discuss much questions because you don't get much question from those areas in the yellow paper. That's the reason, right? Now isomerism means is like this. Okay, let's see now in paper also there. Isomerism means, okay, forget about this. I'll share the screen. I'll use the white background for the explanation. I'll give a small description about this isomerism. Now if you want, you can go to, they have given a long paragraph, this page 17, 18, like all these IUPAC names in the resource book, right? Step by step they have given all this, but no need to memorize all these one by one. If you can do it straight away, if you can write the name, they will now ask all this one by one. write all this. So they are given like here, summarize the stepwise approach. Here the steps are, they will never ask these steps. So you have to remember how prefix hydrocarbon name and service like that, they are given a long paragraph, but not necessary. Now the next part is isomers, isomerism. You can see page number 21 in the resource book. Right? If you write here page number 21 reference in your resource book, if you have got a printout here, isomerism, these are the MCQs. From 1995 I have given questions here. Wait, let me tell you what is the meaning of isomerism first. Since you have not done theory and I think none of you have done the theory yet, therefore I told you I'll give a small short note or summary, and then after that you can do the questions without wasting much time on theory. For some organic compounds, the same chemical formula, but you have different structures. That means the presence of different structures for the same chemical formula. That is called isomerism. That is called isomerism. What is isomerism? The same chemical formula but having different structures for the same chemical formula. So let me explain you that using an example. I'll give one example. Now if you take CH3, CH3, CH2, CH2OH, and if you take CH3, C double bond, CH3, okay, I'll put CH3, CH2OH like this. But the most common one, the most simplest one I'll take because you are familiar with that. The same thing I can write this way also, CH3 or CH3. Right. So if you take the chemical formula, both this, how many carbon here? C2. How many hydrogen here? H6. How many oxygen here? 1. Chemical formula same. This one also, how many carbon here? 2 carbon. How many hydrogen here? 6 hydrogen. How many oxygen? 1 oxygen. Both having the same chemical formula. C2H6O, C2H6O, but you can see this is alcohol. This is ether. Totally different. This one is polar, that one is non-polar. Alcohol is polar, this one is non-polar. Ether like for the solvent extraction, I mean for the extraction of plant oil also we use ether. Like it's like wax, like, you know, a non-polar. Non-polar. Both are organic. You can see same chemical formula, different structures. So these two are isomers. These two are isomers. Functional isomers, because functional group different. I'll give one more example. Rather than writing the thought, you should understand what it is. That is the most important thing in A level. Actually, even if you memorize the whole resource book or the syllabus theory, you will not be able to get even S pass by, because that's competitive the A level exam or local. Right? Now, one more thing. If you take now aldehyde CHO, look at here, CH3, CH2, CHO. This is called aldehyde. What is this called? Propanol. Propanol. For this same, okay, what is the chemical formula? C3, how many hydrogen here? 3 plus 2, 5, 5 plus 1, 6. C3H6O, right? C3H6O, that is called propanol. Now, this propanol, I can write, this is aldehyde. Propanol is an aldehyde. CHO is terminal aldehyde group. I can write a ketone also for this if I want. CH3, CO, CH3. What is this? Propanone. What is it called? Propanone. It's a ketone. Propanone. Name ends in on. Ketone. This aldehyde. Name ends in L. Propan means what? Propan means 3 carbon. Both these 3 carbon. This one is L. That one is on. L means aldehyde. On means ketone. So this is a ketone. Like commercial we use here acetone. Nail polish remover. Acetone. Acetone. Nail polish remover. The ladies to remove cutex and all. So this also having the same formula, C3H6O, right? Same chemical formula, but you can draw 2 different structures. So therefore these 2 are called what? Isomers. Isomers. Now you understand the meaning of isomerism. Isomerism or isomers means having different structures Existence of different structures for the same chemical formula. If you can write it in your short notebook, the existence of different structures for the same chemical formula. So the red one I have highlighted, same chemical formula. What is isomerism? Isomers means what? Isomerism means, it's a noun, existence of different structures for the same molecular formula. Is existence of different structures for same chemical formula. If you only can copy down this one sentence, that is the meaning of isomerism. Chemical formula same, but C3H6O. Is that clear? Is that clear? Understood now? That's the meaning of isomerism. Isomerism, there are different types. So I'll give the summary, classification. I'll do one example. This is called functional group. What is this called? Functional group different. First one, the functional group is aldehyde group. The other one, functional group is ketone. This is aldehyde. Always is come to the terminal. Can you remember when you write the IUPAC name also? Here the is can be anywhere in the middle. So this is ketone group. Both having the CO group, that is called carbonyl group. To both this carbonyl group, this is called carbonyl group. It is common to both. Carbonyl group. It's common to both. Somewhere in short form we write here COH. Like if you want to isolate this separately, the functional group only, this is called CORR, like this. R means alkyl group, ethyl, methyl, whatever. That is the ketone. So that's how we write. Now, one more example. Now that they are functional, what is called functional isomerism. What is that called? Functional isomerism. I'll do one more example. If you take propanol, what is propanol? Propanol. Propan, I'll write 1-ol. So what is the chemical formula of propanol? C3. Okay, I'll draw the structure. After that, we'll get the chemical formula. Propan 1-ol. Propan 1-ol. Propan means, okay, let's see whether we can build the structure for this. Propan means 3 carbon. 1-ol means at the beginning of the first carbon OH group. 1, 2, 3. Let's build this is the IUPAC name. Propan 1-ol. 1 means, okay, I'll write the name here. 1, 2, 3. The first carbon, what? 1-ol means first carbon, there's a OH group. Are there any other side groups? No. Methyl, ethyl, nothing, right? Cyano, bromo, iodo, chloro, nothing. Therefore, how to complete the rest? You have to add hydrogen. So how many hydrogen here? Around this, there must be 4 bonds. So I have to add 2 hydrogen here. This one, how many hydrogen? 2 hydrogen to make it 4 bonds. Here, how many hydrogen should I add? 3 hydrogen to make it 4 bonds. Now, what is this? If you want to rewrite this again, that is CH3 group, this is CH2 group, and this is CH2OH. Okay. Now, this is the structure of the propan 1-ol. Now, so what is the chemical formula? Okay, we'll write the chemical formula. C3 carbon, C3. H, how many hydrogen here? Look at the second one. 2 plus 3, 5. 5 plus 2, 7 plus 1, 8. C3H8O. This is the chemical formula. For the same chemical formula, I can draw one more structure. So this is the first isomer. And the second isomer is this. I can write propan 2-ol. Position of the OH group I can change. Then it will be a different compound. Propan 2-ol. Properties will be different. Propan 2-ol. How to draw this structure? Propan means prop means 3 carbon. Propane, the alpylic acid and the C3H8. Propan 2-ol means what? Attach OH group on the second carbon. You can start numbering either side 1, 2, 3 or this side 1, 2, 3. No problem because it's same thing. Right. It doesn't matter either you start from this side number or this side number, same thing because you get number 2 OH. Now you have to add hydrogen for this 1, 2, 3. Here to make 4 bonds, this side also you have to add 3 hydrogen. So if you combine this and write the structure, this is called the displayed formula. If I add this one, you have to add H here because to make it 4 bonds. Now you can see CH3, CH, OH, CH3. Check whether this also having the same chemical formula. What is the chemical formula here? How many carbon here? C3. This also having the same chemical formula, right? C3. How many hydrogen? 3, 3, 6. 6 plus 2, 8. 8, 8. Oh, yeah, both the same chemical formula. Same chemical formula, but you get two structures. C3H8O. Number 1 and number 2 both having the same chemical formula. You can check this. So both are alcohol, not functional isomers. Position isomers. These two are called what? Position isomers. Positional isomers. Position isomerism. Why? The functional group, the carbon to which the functional group attached different. First one, the first carbon is attached, the other one, second carbon. So are they having the same physical and chemical properties? No. Their chemical properties different, their physical properties different. Right? Not the same thing. Properties different. Both are alcohol. That's called position isomers. I'll tell one more example for these position isomers. Previous one I told functional isomers. Position isomers, one more example, say butane. I'll write here butane. For butane, what is butane? Butane. Okay, I will say butene. Okay, forget about butane. Butene. What is butene? Butene. Now butene means ene, alkene. It's ended in ene. But means 4 carbon. So butene, what is the chemical formula? C4 alkane. You have done in oral chemistry. C4H10 butene. C4H8, sorry. C4H8. It's alkane, butane, C4H10. This is C4H8. Now let's see. Butene 1, 2, 3, 4. So you can put the double bond at the beginning and right here. Okay. Why it is? Because of ene butene, we put the double bond at the beginning between the first 2 carbon. So you fill the rest with hydrogen. You fill the rest with hydrogen to make it 4 bonds around each. So here I had to add 2 hydrogen. Here how many hydrogen? Only 1 hydrogen. Here how many hydrogen? 2 hydrogen to make it 4 bonds. Here how many hydrogen? 3 hydrogen to make it 4 bonds. Okay, we'll write the, now this is called the displayed formula. I'll write the structural formula now. CH2 double bond CH CH2 CH3. Look at what the chemical formula. See whether you are getting the same chemical formula. How many carbon here? 4 carbon. C4. See whether there are 8 hydrogen. 2 plus 1 3, 3 plus 2 5, 5. So there is 8 hydrogen. 8 hydrogen. 8 hydrogen. So actually this name is not just butene. How to write the name here? But we have to represent at between which carbon, at the beginning of which carbon the double bond. So this is called but 1 ene. But 1 ene. And not just butene. But 1 ene. Why? We can draw more than one structure for this. So this is the first structure. And the second structure will be this. Same thing, no need to write both this in the exam. The displayed formula is structural formula. Structural formula is even enough. The second structure for butene is this. There are 2 isomers, 2 structures of the same chemical formula. You can shift this double bond from here to here. You can shift the double bond here and go to the next structure. CH. Shall I, without wasting time? Okay, if you want, I'll write from the beginning, no problem. You can put here 1, 2, 3, 4. I'll put the double bond in the middle. I'll put the double bond in the middle. And then what happened? This become how many hydrogen? To make it 4 bonds? 3 hydrogen. Right? To make it 4 bonds, this side 3 hydrogen. 3 hydrogen. After that, here how many hydrogen? Just 1 hydrogen. Here also 1 hydrogen. So then it becomes like this. CH3 CH double bond CH CH3. What is this? But what ene? But tell me, what is but what? 2 in 1 in 3 in what? 1 2 3 4. Yes. But at the beginning of the second carbon double bond. At the beginning of the second carbon double bond, this become but 2 ene. So these two are isomers. Why? Different structures for the same chemical formula. C4H8 butene. First isomer is but 1 ene. Second isomer is but 2 ene. Is that clear? So this is called position isomers. What is this called? Changing of the position of the double bond. By changing the position of the double bond, we can make two isomers. By changing the position of the double bond, we can make two isomers. There are two isomers for this compound. Okay. Now you got the concept, right? There are we can classify isomerism like a functional isomerism due to the changing of the functional group. Position isomers due to the position of the changing of the position of the double bond or the position of the double bond or the functional group. Functional isomers, position isomers. Then there's one more, chain isomers. Chain isomers means, look at here, carbon chain. You can, okay, say butane. Okay, let's see, C3H10, this is called C4H10. I read here C4H10 butane. Right, butane, one isomer you can draw like this, linear one, 1 2 3 4 carbon, complete the rest with hydrogen to make it 4 bonds. Shortest method, put 3 hydrogen for the terminal and put 2 hydrogen for the middle one. Now okay, CH3 CH2 CH2 CH3, this is butane. Now you can reduce the carbon chain. Second structure, you can take this CH3 out and attach to the middle carbon. Now this the carbon chain I reduce from 4 carbon to 3 carbon and take this terminal CH3 group to here. Then this becomes CH3, this becomes CH3, and here I add hydrogen to make it 4 bond. Now what? See whether there are 10 hydrogen here in the second one. Second one also has 10 hydrogen. Right? Second structure also has 10 hydrogen. First structure also has 10 hydrogen. What did I do? I reduced the longest chain from 4 carbon to 3 carbon. Here 4 carbon in the longest chain, here 3 carbon in the longest chain. Then this become what? Side group. So we get two different names. That means these are two different structures. If we get two IUPAC names, they are different. But the chemical formula same. Same chemical formula, but two different structures. This is called just butane. What is this one? This is, okay, let's see, number it here. You can start numbering from left side to right side, no problem. 1 2 3. What is this? You're right. What is this called? Methyl group ne? What is this? 2-methyl propane. No space between methyl and propane. 2-methyl propane. 2-methyl propane. But the same chemical formula. Both, count the number of carbon and hydrogen in both. C4H10. First one is butane, second one is 2-methyl propane. Different structures for the same chemical formula due to the changing of the what? Nature of the carbon chain. Carbon chain is different. Now this one 4 carbon chain, this one 3 carbon chain. Carbon chain, due to the changing of the carbon chain, that is called chain isomerism. What are the 3 types of isomerism I taught you now? Without theory now you learn all 3. If you can keep everything what you learn in your head like this, then no need to memorize the theory note again and again, no need to waste time. So what are the 3 types of isomerism? First I told you, functional isomerism, due to the changing of the functional group. Right? What is that? I told L and say propanol and propanone, like that. Functional isomerism. Second one I told position isomerism, due to the changing of the position of the double bond, due to the changing of the position of the OH group. Third one, that is this one, chain isomerism. These are the 3 types of isomerism due to the changing of the structure. Due to the changing of the structure. Due to the changing of the structure, there are 3 isomers: chain, position, and functional isomerism. Right, very good. Okay, you remember this. So now the isomerism nearly 40% done now. So actually I can give a summary also. There are isomerism, you can divide into isomerism. If you can copy down this summary, isomerism in the resource book I pay after that, also you can read after the class if you want. Then no need to write a notes. If when the resource book is there, no need to write, waste time for the notes again. You can refer that and do it. Isomerism, there are 2 types. One type is what? Structural isomerism. Then this one is stereoisomerism. That one I didn't do today. That is the next part. I'll discuss that next day. The stereoisomerism. Stereoisomerism. Please, you better copy down this summary of the isomerism. Then today I completed this one, the structural isomerism. Due to the changing of the structure can be changed due to the changing of the functional group. Then we call it what? Functional isomerism. The structure can be changed due to the changing of the position of the double bond or triple bond or the functional group due to the changing of the position, because OH group you can put at different places on the carbon chain. Position isomerism. The other one is called functional group isomerism. Functional group isomerism. So if you want to write here one example, so this one you can write here itself. If you want to write the example I gave, propanol, CH3, CH2, but I don't waste time again because I explained that in detail. Propanol and propanone, CH3, COCH3, propanol and propanone. You can expand and do it if you want. Later you can copy down, but here no space to write everything. Therefore I'll write is first one is aldehyde, second one is ketone. Functional group different. Then I told position isomer. So but 1 ion and but 2 ion. So example CH3. Say wait CH2 CH2 double bond CH CH2 CH3. The other one you can write CH3 CH double bond CH CH3. So it is due to the change of the position of the double bond. The other one functional group. Functional group I have given twice. No, sorry. This should be chain isomerism. Sorry, chain isomerism. So that is due to the changing of the carbon chain. So this is, you can write the name. I don't have space here. You can write here aldehyde. Chain isomerism, you can write butane, CH3, CH2. Leisurely at home you can write the name of each separately, the IUPAC name. These two IUPAC name and write both have the same chemical formula. Both these have the same chemical formula. Both these have the same chemical formula. So both these having the same chemical formula. At home you write the chemical formula and write the name under each. You get different names but the same chemical formula. Is that clear? You get the different names. Functional isomers I have got 2 examples. Position isomers 2 examples. Chain isomers 2 examples. I mean 1 example for each. Okay. So that is done today. Next day we'll do the questions, but before doing the questions I'll complete this part. The stereoisomerism. There are 2 types. Next day I'll explain that. Diastereoisomers and enantiomers. Diastereoisomers and enantiomers. Don't worry, I'll explain with example these 2 next day. So without theory you can do after this I'll discuss all the questions with you, then you will understand how easy it is, right? Okay, so then you can copy down this summary. It's 7:34. So I'll stop for today. We'll continue the rest next week, right? If you have any question you can ask even through the WhatsApp. Chanu, you have to complete the first 4 tutorials and get the record in the last month, as I told you. And if you can keep the printout of the isomerism 2 tutorials that I have posted yesterday, right? Okay, then good night and God bless you. You can I don't erase it now itself. I'll leave it for a few minutes. You can copy down this nicely in the right now, right? Okay, good night and God bless you.